Today we are gonna solve some questions on trigonometric functions, right? So they are some typical questions and they are very important, right? So let's see. Now we will start from the like 6, 5, 4, 3. Okay. Now so cos 4x equals to this, and we have to prove it, right? Now all the formulas and some questions I already taught about you. Now so let's see how to do this. Now cos 4x is equals to 1 minus 8 sin square x into cos square x. So we have to prove this, right? So how can you do this? Now see, here 4x and here it is going to be x. When angle reduced, we try to break this angle in the smaller part. So how can you do this? One way is you write like this: cos 4x as cos 2x plus 2x, or 3x plus x, and apply some formula. Like if you break it like as this, you can one way of doing so is 2x plus 2x, right? Or you can break it like this: cos 3x plus x. But so you have to be careful about this, right? By doing practice, we have to do a lot of question in trigonometry, and that is the only way to understand this. If you are not going to solve some questions and do a lot of practice on this topic, then trigonometry is going on the from your head, right? So keep this in mind. You have to do a lot of questions in order to understand trigonometry. Okay, so you can do this, or you can go with some other way, right? So these two are going to be a little bit lengthy, right? So and how we do know about it, how to solve it? By doing practice. Okay, if you follow this way, right? If you follow this way, then you are going to get 3x, right, in your solution. And we don't and now you have to further break 3x as x plus 2x, right? And it is ultimately give you like this term, right? If you're going to break 3x again and in x plus 2x, then it is same as 2x plus 2x, right? And again you are going to break 2x as x plus x. Okay, so better is to just leave it. Okay, now if you break it like this, 2x plus 2x, then you are going to get some terms in 2x, right? If you expand this, you are going to get 2x, right, in your expansion of cos 2x plus 2x. But if you say that there is a formula of cos 2x, right? Cos 2x is equals to cos square x minus sin square x. Okay, so there is a formula cos square x minus sin square x, cos 2x. So better we go with that one. Let's see how. Now cos 4x can be written as 2 into 2x, right? And it will act as x. Cos 2x is equals to, and how do we have to make the formula? 1 minus. So if you see that sheet where I have taught you about the formulas, then you are going to get this: 1 minus 2 sin square x. And what is x? X 2x. This is the formula, right? And it means I am using this: cos 2x is equals to 1 minus 2 sin square x. So why I am doing so? Because and now see, if you apply cos 2x plus 2x, then you are not going to get 1 directly. It is a way you can do by that way also, but you have to take your optimal path so that time we can manage time also, right? Now cos 2 into 2x is going to be this, using this. So we are going to get 1. Now I have to convert this into this. Okay, so what I can do now, it is nothing but this is going to be 1 minus 2 sin square 2x. Now this can be written as 1 minus 2 sin 2x whole square, right? Now sin 2x can be broken again, right? So there is a formula: sin 2x is equals to 2 sin x cos x, and I already told you how to get that formula, right? So 1 minus 2, this is going to be 2 sin x cos x square. Now 1 minus 2, if you square this is going to be 4 sin square x and cos square x. Okay, so 2 folds are 8. So we get it, right? So RHS. So this is how you have to do. So here we are using half angle formula. I already told you what half angle formula is. So this angle is going to be reduced by half and then further reduced by half. So this is how you can do this. Okay. Now next is this. So this is based on your CD formula. So you have to do a lot of question in order to understand when CD formula is applied. Now one way is when two like terms is being added. Tan means like sin x plus sin x, cos x, sin x plus sin 2x means angled by differing angles. Same trigonometric function but different in angles. So like this. Now in order to, you have to prove cot 3x. So cot 3x, in order to prove cot 3x, you have to make cos 3x upar on the numerator and sin 3x in denominator. So how can you do this? Now see, you have to make cos 3x. Now if you remember the formula, if you know what is the formula is, and the better thing is keep the formula with yourself, right? And initially try to solve, means now you have to solve this formula. Take your sheet with yourself and just match them, which formula is suitable to solve this, right? So if you apply cos 4x and cos 2x, right, and see the formula. Now what is the cos c plus cos d? C plus d divided by 2. 4x plus 2x divided by 2 is going to give you 3x, right? So somewhere you are going to get cos 3x, right? And leave the subtraction part, and that is going to be cancelled out. Okay, so I know it, but this is a way. By doing some practice, you are going to get it. Now cos 4x plus cos 2x, I am applying this formula, so I am just keeping them together. Cos 2x and plus cos 3x. And same way over here also, sin 4x plus sin 3x and plus sin 3x, right? Now apply CD formula over here and over here. So cos c plus cos d is cos 2 cos this plus this 4x plus 2x divided by 2, and cos 4x minus 2x divided by 2 plus cos 3x, right? Now similarly for here also, so 2 sin 4x plus, okay, here it should be 2x, yeah, 2x upon 2, and sin c plus sin d is 2 sin c plus d divided by 2, and cos 4x minus 2x divided by 2 plus cos 3x, right? It is sin. Okay, now what you can see, cos 3x is common, right, from here, and sin 3x is common from here. Yeah, excellent. So take them as common. Now cos 4 plus 2, 6 divided by 2, 3. So cos 3x upon sin 3x. So what we are remaining with here, it is going to be 2, and it is cos, okay, 2 cos, I guess, x, right? 4x minus 2x is 2x. 2x divided by x, 2x. So cos 2x plus 1, and here also the same thing, right? So this will cancel out, and sin cos by sin is cot. So they are very simple, right? But interesting. So this is how you can do this. You can do more problems, and then it will be easy. Now let's move for the fourth question. Now fourth question is I think this kind of question I already told you, right? So it is important. These questions are from exemplars, right? So exemplar have some pretty good questions. Okay, so you need to solve this also. Now this is what we have, and we have to get the value of tan 2a, and I already told you tan 2a. For tan 2a we have to prove something. Now in order to get means this term, so we have to break tan 2a in terms of a plus b and a minus b. That is the important part, right? So how can you do this? You can write it like this: tan a plus b plus a minus b, isn't it? You can write like this: a plus b plus a minus b. Now b will cancel out, and it is going to be 2a, and we are also able to break this 2a in a plus b and a minus b, so that we can get this. Now it is easy. Now apply formula as tan x plus y. So what is tan x plus y? Tan x means tan x plus tan y upon 1 minus tan x and tan y. So this is very simple also. But these are literally very simple, right? When you see the solution, but they are the really good concepts initially, right? So if you are doing it for the first time, maybe it is very difficult for you, but by doing practice, it is going to be easy. Tan a plus b. What is the value of tan a plus b? P q upon 1 minus p q. That's it. Okay, so this is how you can prove it. Okay, next is, so whenever I'm solving some question, better is you try to solve it by yourself first. Okay, so you can pause the video and you can solve it by yourself first. Now here, right, so I'm trying to cover each type of questions we have, means each type of problems that are based on each type of formula you have with yourself. Okay, now what you can do, how can you solve this? Cos theta by 2 minus cos 3 theta cos 9 theta by 2. So it is a very so we have to prove this, right? So this is question number 3. Now the better practice is, whenever you see cos theta with multiplication, or cos theta sin theta with multiplication, or sin theta cos theta, means sin theta with multiplication, the better practice is you multiply and divide by 2. See, you have a formula like 2 sin a, 2 sin a, okay, 2 cos a cos b, right? There is a formula 2 cos a cos b. I already told you, right? You in your formula sheet you can see this. 2 cos a cos b means two multiplying terms, cos a and cos b, is equals to cos a plus b plus cos a minus b. So that formula comes into act, okay, when two cos terms are being multiplied, sin terms are being multiplied, sin cos is being multiplied. Okay, so that formula is used here, right? Because cos is multiplying, cos is multiplying. Okay, so how, but in order to apply that formula, you have to means there should be a 2, right, with this, because the formula is like this, 2 cos a cos b, right? So what we can do, you basically multiply and divide by 2 and take the numerator, the 2 which is in numerator inside. So 1 upon 2, this is going to be 2 cos theta by 2, 2 cos 3 theta and cos 3 theta by 2. It is 9, right? So 9 theta by 2. Now 2 cos a cos b, you can see the formula, right? It is going to be cos this plus this, theta plus theta by 2, plus cos theta minus theta by 2, and the same thing with this also, minus cos 3 theta plus 9 theta by 2 and plus cos 3 theta minus 9 theta by 2. Okay, now let's add them. 1 by 2 cos 3 theta by 2 plus cos theta by 2 minus, this one is minus, so minus cos 15 theta by 2, what we have to prove, yes, and this is going to be 3 to 6, yes, so it is going to be, this is minus, this is also going to be minus, right? So cos 3 to 6 minus 3, minus 3 theta by 2, right? So okay, so what you can see, cos 3 theta by 2, and here it is minus cos minus 3 theta by 2, but cos minus theta is theta, so this minus can be removed, or can we make as positive. Now this will cancel out with this, so it is going to be 1 by 2 cos theta by 2 minus cos 15 theta by 2. Now you have a formula, cos c minus d, the CD formulas, right? You can apply them over those over here. Now let's apply them. 2 cos c minus cos d is 2 sin this plus this, theta by 2 plus 15 theta by 2 divided by 2, right? C plus d divided by 2, and then sin c minus d means theta by 2 minus 15 theta by 2 upon 2, right? This, the 2 will going to be cancelled out with this, and if you add them, theta plus 15 theta is going to be 16 theta, right? 15 theta plus theta is 16 theta, 16 theta divided by 2 is 8, 8 divided by 2 is going to be C minus d. Okay, the formulas are going to be same. Let's check it. Okay, 2 will divide with this. Now theta plus 15 theta is 16, 16 divided by 2, 8, 8 divided by 2 is 4. So cos theta this going to be same. This is okay. Cos theta by 2. Okay, let's see this. Okay, now 15 plus theta is 16, 16 divided by 2 is 8, 8 divided by 2 is going to be 4, so it is going to be sin 4 theta, and theta minus 15 is minus 14, minus 14 divided by 2, 7, 7 divided by 2 is 7 by 2, so this is going to be sin 7 theta by 2 with negative sign over here. Why? Because of this minus. Alright, so here it is going to be sin 7 theta and sin 8 theta. So 1 by 2 cos 3 theta is going to be cancelled out with this, cos c minus cos b, Is it going to be cos t minus 1? Okay, alright. Cos t minus cos d is, okay, it is minus 2. Okay, the formula of cos t minus cos d is minus 2 sin theta plus, right? So you know that. So it is going to be minus over here. So this minus will make it positive, and because maybe there is the upon 2 also, right? I maybe missed it. So this is how you can do this, okay? Or there is something printing problem, but this is how you have to do this, okay? All right. Now move to the next question. So next is this. So these means first and second type of question you have already done. Means such type of question you might have done in your 10th class. Okay. So let's see how to solve them. Okay. So better first thing is simplify that. Means what the value means you have to calculate the value of this. So how can you do this? You better is to simplify it, right? So you can write it like this: a plus b upon a minus b plus like this under root this a minus b upon under root a plus b. Now add them. Means adding is just take LCM. So you know that how to take it. You multiply them. A minus b is going to be a minus b, and this will cancel out. Means this will multiply with this. It is going to be a plus b, and how it is going to be over here. This will this, and this is going to be cancelled out. So I think you know that. Okay. So how to do this? It is very simple. Now 2a upon under root a square minus b square. This is what you get. Okay. Now, so it is just a simplification, right? So now the next thing is to take a from here like this: 2 upon under root a square minus b square upon a. This is what we can write it like this. Okay. So you know that. Now take a inside: 2 upon under root a square minus b square upon a square. Both means the same thing. So this is how you can do this. Now separate it. 2 a square is going to be cancelled out. 1 upon b square by a square. 1 minus b square by a square. Now what is the value of b by a? So it is very simple, isn't it? 2 upon under root 1 minus b square by a square means 10 square x. So that's it. Okay. So this is how you can do this. This is very simple. Now the next is tan a plus sec a is this. So a better practice is you simplify them in terms of sine and cos. Okay. So that is better way to understand it, right? So we are generally familiar with sine cos only, right? So it is a good practice. You can write it like this. Means I am taking LHS: sine a upon cos a plus 1 upon cos a minus 1, and upon me sine a by cos a minus 1 upon cos a plus 1, right? If you take LCM and add them, you are going to get this: sine a minus cos a minus 1, like this, plus 1, and this is going to be sine a minus plus cos a minus 1, right? So after simplification you are going to get this. Now if you take minus as common over here, now but if there is 2 terms, so you know how to rationalize it, but in 3 terms you have to do like this. Okay. So it may take, means in this case calculation may be a little bit more, but this is how you have to do. Now multiply it with sine. What I can do, you can write like this: sine a minus cos a minus 1, sine a minus cos a minus 1. So take the, means it is not important to do it like cos a minus 1, or you can write it like this: sine a minus cos a minus 1, sine a plus cos a minus 1, right? So this is also a way to do so, right? Now multiply it. Now here it is a b, a plus b, a minus b. So I can directly like this: sine square a minus cos a minus 1 whole square, right? And here it is a minus b whole square. So I can write it like this: sine a square plus cos a minus 1 square minus 2 sine a cos a minus 1. This is how you can do this, isn't it? So it is very simple. Now sine square a minus, if you simplify it, it is going to be cos square a minus 1 plus 2 cos a, right? Now, and here it is going to be sin square a plus cos square a plus 1 minus 2 cos a minus 2 sin a. Okay, one more thing. Okay, we are left with something. It is going to be sin square a, it is going to be cos square a, it is going to be plus 1, it is going to be minus 2 cos a. So, okay, minus 2 sin a cos a plus 2 sin a, right? Just multiplication. Now, what you can see, this is going to be 1. Okay, now, and one more thing. Yeah, now, if you take, or you can write it like this, sin square a minus 1, right? 1 minus sin square a is cos square a. So, sin square a minus 1 can be written as minus cos square a, isn't it? So, sin square a minus 1 can be written as, so I am doing it over here. So, this can be written as sin square a minus 1 can be written as minus cos square a, and minus cos square a minus cos square a is minus 2 cos square a. So, just pay attention, plus 2 cos a, right? So, this is how you can do this. Now, this is going to be 1 plus 1, 2. So, this is going to be 2, and here, what you can do, you take minus 2 sin a as a common from these two. So, this is 1, this is 1, so these have been solved. From these two, you can take minus 2 cos a as a common. So, 2 minus 2 cos a. If I take minus 2 cos a as a common, this is going to be 1 plus sin a. And this is going to be so this is going to be plus 2 sin a, right? Now here, from here you can take 2 cos a as a common from denominator, 2 cos a, so it is going to be 1 minus cos a, right? If I take 2 cos a as a common, so it is going to be this. Now from here, what you can see, from this and this, take 2 as a common, so it is going to be 1 plus sin a minus 2 cos a and 1 plus sin a, right? So 1 plus sin a is common from the above, and in fact 2 is also common, right? 1 plus sin a. So what is going to be remain with 1 minus cos a upon 2 cos a into 1 minus cos a. So this is going to be multiplied, cancel out, this is going to be cancelled out. So what we have to prove? Yeah, we got it. 1 plus sin a upon cos a. So this is how you have to do, right? So looks like a little bit lengthy, but in 11th class we have to you must have habit to solve these type of questions, right? So this is going to be like this. Okay, so these are some questions. Okay.